Good morning, everybody. Today we are going to discuss how to convert a two-column proof into other formats, specifically a flowchart and then a paragraph proof. So we are just going to complete this by a couple of examples of each conversion. So the first thing we have is a proof. So we're given that A, B, and C are collinear. B is between points A and C, and we're also given the lengths of each of the segments. So in the end, what we want to prove is that 2 equals x, or x equals 2. That's the same statement there. So the first thing we want to do is just sketch a quick little picture so we can see what we're talking about. So we know that B is between A and C. So let's plot our points A and C. B is between them. It never says that it is the midpoint. So I'm intentionally going to place B off-center, just so that we're not tempted to assume that it is the halfway point. Some other given information is that the distance from A to C is 14. We are told that the distance from A to B is 5x. And then we are told that the distance from B to C is 2x. So this gives us a little bit of a visual of what we see going on in our picture here. So, from the beginning, A, B, and C are collinear. B is between A and C. So when you have a two-column proof, the first statement you make, you always want to start with what's given. Also, it's worth mentioning now that we're given that AC is 14, AB is 5x, and BC is 2x. So from there, the next logical thing we can jump to is saying that AC is equal to AB plus BC. So basically, the whole segment is equal to this part plus the second part. And that's actually allowed by the segment addition postulate. Excuse me. The next thing we do is we turn AC into 14, because that was given. We turn AB into 5x, because that was given. And we turn we turn BC into 2x. That was also given. So that change is what we call substitution from those given lengths. The next thing we can do is say 5x plus 2x is actually 7x. So you can call that simplification or combining like terms. Both reasons work here. Next thing we're going to do is divide by 7 on both sides of our equal sign. And this is the division property of equality that says we're allowed to do that. And then after simplification, we do end up at 2 equals x, which is what we originally wanted to prove. Now, given this proof, this two-column proof that we just kind of went through how it works, we want to actually convert it into a flowchart. So the first thing you want to do is you want to start with a box of given information. Now we see in our original proof that all of our given information is kind of mentioned at the beginning. So we can actually do one flowchart box where we are mentioning all three of those points. So A, B, and C are, and I'm going to have to abbreviate here, collinear, C-O-L. B is between, so B/W stands for between A and C. And we also know that AC was equal to 14. AB was equal to 5x. And we know that BC was equal to 2x. And the reason we know that you can write below the box right here is you can say that that is given. From there, that's what this arrow is saying. From there, we were able to make the statement, and we're just going to follow each line in our proof here. So we did these first two lines, those were given. The next line is the next box we're going to draw. And that is saying that AC is equal to AB plus BC. And right below that box, we're going to write what that reason was. So AC equals AB plus BC. And in our chart, it says that was the segment addition postulate. So I'm going to say segment, SEG, addition, postulate. So I am abbreviating here, but the full terminology is in your chart. From that reason, the next line we have was that 14 is equal to 5x plus 2x. The reason we were allowed to do that was substitution. So I'll abbreviate that as SUBST. After that, the next thing that we were able to say was 14 is actually equal to 7x. And that was just simplification or combining like terms. So I'm going to do CLT. That stands for combining like terms. Now the next thing we did was we showed the step of dividing by 7, but what that actually resulted in was 2 equals, oops, forgot my equal sign. Was that 2 is equal to x. And the reason we were allowed to say that was the result of division, and then, once we divided, we simplified. Okay, so this flowchart is basically showing just the flow of the logical reasoning. So we started with given. From there, we jumped to AC equals AB plus BC. That was because of the segment addition postulate. We then were able to flow to 14 equals 5x plus 2x by substitution. From there, we said 14 equals 7x by combining like terms. And then we divided and simplified to result with 2 equals x, which was the end of our proof. So that is just an alternative way to display the same logic and the same reasons as the 2-column proof. Something else we can do is take that 2-column proof and we can express it as a paragraph. So basically what you do is you just read through this chart, but turn it into complete sentences. So we could say, by given information, we know that A, B, and C are collinear, and that B is between A and C. Also given to us is that AC equals 14, AB equals 5x, and BC equals 2x. So you basically take each line of the proof and just express it as a complete sentence. We can say that AC equals AB plus BC by the segment addition postulate. Using the substitution property of equality, 14 equals 5x plus 2x. And you can alternate if you start with the left or start with the right, but make sure that the reason and the statement are both included in the same sentence. Then 14 equals 7x by simplification or combining like terms. Using the division property of equality, we are able to divide by 7 on both sides of our equal sign. And finally, using simplification, 2 equals x. And we know that we are finished with this proof because that was what we originally wanted to prove, was that 2 equals x. Please let me know if you have any questions or need any more help with this video.